Now let's look at another CPM example to get more practice. Again, we're going to construct an activity on arrow network for the given action plan. So in this table, the cost and the responsible people for those tasks are omitted, and we're going to just focus on the time planning part. So in this table, we can see that the first three activities are A, B, C, because these are the three activities that do not have predecessor. So what does this mean? These three will be the three activities that come out from the starting node of your first event of this project. Then we can see A is the predecessor of both D and E. Okay, so we were going to have a node after A, and after that node, both D and E will come out as arrows. Then B is a predecessor of F, C is a predecessor of G, D is a predecessor of H, and then both E and F are the predecessors of I. So E and F will end to the same node, and then from that node, we will have an activity, which is I, coming out. So with this simple analysis, we're going to draw the activity on arrow network first. So we're going to start with a node, which is our starting node. And from this node, we're going to have three activities. A, B, and C. Recall that A is the predecessor of both D and E. So we're going to have a node after A, then D and E both come out of this node after A. Then B is a predecessor of F. C is a predecessor of G. So after B, we're going to have F. After C, we're going to have G. Then after D, we're going to have H. Both E and F are the predecessor of I. So we're going to have one node connecting E and F. So I'm going to maybe change this one here. And after this node is the I. With this, we completed all the tasks with their predecessor relationship. So start with A, B, C, and then after A, we have D and E. After B, C, D, we have one activity, F, G, H. E and F end at the same node, which is followed by I. Okay, so that means H, I, and G are the last activities of this project, and they are going to connect to the same ending node. So I'm going to connect them. To the same ending node. So this is the network that we draw following this action plan. The main focus is the predecessor relationship. Then we're going to add the duration of those activities after the activity using a comma to separate them. Those durations are given in this action table. So A takes 8 days, B takes 20 days, C takes 33 days, and so on to complete. So we add those duration on the arrow after the activity name and a comma. Now, with this given information, we're going to start with a forward-going calculation to find out the early times for the activities and the event. Now, let's look at our first event. Our first event, node 1. This node represents the beginning of this entire project. So the beginning date will be day 0. And this early time for this event will come under activity A, B, and C to be their early start time. And if it takes 8 days to complete activity A, then the earliest time to have A completed will be day 8. Similarly, if it takes 20 days to complete B, then the early finish date for activity B will be day 20. And for C, it will be 33. So we use the early start time of an activity plus its duration to get its early finish time. And for the following events, event 2, 3, and 4. Since there's only one activity that goes to each of those nodes, that activity's early finish time will become the early time of that node. So what does that mean? Take node 2, for example. Node 2 represents the finishing of activity A or the beginning of activity D and E. And the early date of finishing activity A is day 8. So the 8 comes here. And that 8 is also the early start time for activity D and E that follow after this event. So this 8 becomes here and also here to represent the early starting time of activity D and E. So for D, it takes 18 days to complete it. So the early finish time will be, and it takes 20 days to complete E. So the early completing date for E is 28. For activity F, since the early event time for that node before it is 20, so its early starting time is 20, and its early finishing time is 29. Similarly, for G, G's early starting time is 33, because that's the event early time, and it takes 10 days to finish it, so its early finishing time is 43. Now we're going to continue. For event 5 and 6. So event 5 is simple. This 26 goes here because there's only one activity that goes to this event. But for event 6, there are two activities, E and F, both go to this node. Then let's think about which one do we use. Do we use the 28 or should we use the 29 as the event early time? That has to do with what this event represents. So this event represented by the 6 is the finishing of both activity E and F, and also the starting of activity I. Since it represents the completion of both E and F, we have to choose this larger number, which is 29. If we choose the smaller number, 28, then it won't correctly represent both E and F are done. Okay, so I encourage you not to just remember, oh, take the bigger number or take the smaller number. Instead, if you understand what this event represents, then you will be able to choose the right number to use. So now this 29 goes here, the 26 goes here, and then we'll be able to calculate the early finish time for H, which is 34, and the early finish time for I is 33. Now we are at this last event. This event represents the completion of the entire project. So the entire project will be completed once H, I, G, which are the last activities to be completed. When these are done, then our project will be done. So now we have to take the activity that complete the last, which is by the 43 days, to be this project's early time. So the project will be finished by day 43 because that's G get finished. Both I and H are finished before that. With this, we finish our forward calculation. Okay, and this is a summary of that past network with all the early time calculated. So we have the early start time, early finish time calculated and written under the arrows for each activity. And we also have the early time for each event. Each event represents the completion of the activities that go before that, and the starting of the activities go after it. Now we're going to go backward to find out the late times for the activities and the events. So to go backward, we start from node 7, the completion node. Since this represents the completion of the entire project, if the early time to finish the project is 43, then the late time needs to be 43. Otherwise, we are deliberately delaying this project. Okay, then this 43 will come above the arrows for those activities that go immediately before this node to represent the latest time that those activities can finish. For example, if we look at H, the latest date to complete activity H is day 43. As long as H is completed before or by that date, the project will not be delayed. Okay, and if it takes 8 days to complete H, then we can start H no later than day 35, because 35 plus 8 equals to the 43. Okay, so this is saying that the latest day to complete H is day 43, and since it takes 8 days to complete activity H, the latest day to start activity H will be day 35. Using the same logic, we'll be able to calculate the latest starting time for the activities. For example, I will use 43 subtract 4, which gives us 33, to be the late starting time for activity I. And for G, it's the same as its early start time, because 43 subtract 10 is 33. Okay, so then this 35 value, this value goes to this event now, because this represents the latest date to start H. Okay, and it also represents the latest date to complete D. So this 35 will go above the arrow for D to represent its late finish time. It takes 18 days to complete D, so the latest day to start D will be 17. And if we look at the event before I here, this 39 here comes to here to represent the latest date to start I is 39, which is also the latest day to finish both E and F. So we're going to put 39 to be here. And it takes 20 days to complete E, so we can start E no later than day 19, and we are good. We won't delay the project. F will be 30 here. Okay, now we're going to look at node 2 now. Node 2 represents the completion of activity A and also the starting of activity D and E. What value should go here? Should it be 17 or 19? Again, if we understand what this event represents, then we'll be able to figure out which number to use. So this represents the latest date to start both D and E. So if we start both D and E by the 17th day, they will both be good. We won't delay them. But if we start both activities on day 19, then E will be good, but D will be delayed. So the answer here will be the 17. Okay, so when we go backward, when we have two activities that come out from one node, then we'll have to choose the smaller number, because if we choose the bigger number, then the other activity with the smaller later start time will be delayed, and that will result in delaying this entire project. So this 17 comes here. 17 take away 8, 9, 30 becomes here 10, and then the last one 33, 0. Now again, for this starting node, we're going to choose the smallest number, which is 0 here. Again, let's try to remember by understanding them. Okay, so the starting node represents the beginning of the entire project, which begins with activity A, B, C. So for A and B, the latest time to start them will be by day 9 or by day 10. However, for activity C, the latest time to start it is 0, is to start now. So we have to start this event by 0. Otherwise, we're going to delay C. Okay, so this is a nicer representation of what we just came up with the numbers. And to wrap up this CPM method, we're going to find where the slack is. Recall, slack is the difference between the late finish time subtracting the early finish time. And if we look at those activities, say A, the slack is the difference between the early finish time and the late finish time, which will be 9 days. So for activity A, you have about 9 days leeway to, if we want to delay it in between 0 to 9 days, then you are fine. The entire project won't be delayed. Or if you pick another single activity, say H, the difference between the late finish time and the early finish time is 9. So again, you have about 9 days leeway if you have to delay the starting of activity H. And we need to be very careful. The slack can only be used once on one pass. Say if you delay this H for 9 days, then you can delay A or D for some extra time. Because A slack is 9, D slack is also 9, H slack also 9. Some people may think we can delay A for 9 days, D for 9 days, and H for another 9 days, which is wrong. The slack is on this entire path. So some other activities, if we look at their late finish time subtracting the early finish time, we can get the slack for each activity. And then the critical path will be the one that has no slack on each of the activity that connects as a path. For example, in this example here, in this exercise here, this will be our critical path, because the early finish time and the late finish time, they are all the same. Okay, so these two are the same, these two are the same. So no slack at all on this path. So this path is called the critical path because all the activities on this path cannot be delayed. They don't have any slack at all. If any of those activities is delayed, then the entire project will be delayed. So activities C and G, or nodes 1 to 4 to 7, is the critical path. And the length of this critical path is 43 days.